Good evening, everybody. Welcome to League of Extraordinary Inventors. I'm your host, Mike from Faraday Research, and welcome. It is Free Energy Friday. As always, we have our regular panel with us. Actually, we've got Mr. G-Man's in tonight, so we can have some fun with Mr. Gerald in Winnipeg. And we got Lulu back this week. We're glad to see her. And for just a note, Bernie, I did send you a link. If you want to hop on at any time, you can do so. It's July 10th, 2026. I hope everybody had a good week. My week has been interesting, to say the least. Very good things are happening. Very good things are happening with my battery cells. We'll get into that maybe a little later in the show, but good evening, Gerald. Good evening, Lulu, and good evening, Mr. Phillip. How's everybody doing?
Hi.
We have Darth Vader.
The Dead Star.
Mike, I am your father. No, I'm just kidding.
You're not my father.
How is everybody?
Good. Yeah, it's been a kind of
really good. Even if I looked like a caveman, I couldn't be happier,
Not you,
It's okay.
Philip. You just need a poutine or two, and you'll be fine.
Yeah.
Yeah, exactly.
I
That's
got my
that's why
nuts.
I'm so happy. I got my poutine, so I'm good.
There
I
you
got
go.
my nuts. I got my
Mike
nuts.
and
They're
his
ready
nuts.
to go.
There you go. You keep your nuts in a jar, Mike. I see.
Yes.
That's awesome.
Yeah, that my
sorry,
wife's
we keep
got 'em.
talking about Mike's nuts.
Yeah.
How are you, Lulu?
I'm okay.
She just did 500 push-ups, so she's good now.
There you go.
Probably more this week. Probably way more than 500 push-ups.
She's here to pump us up.
I mean, one interesting thing, I drove a big truck this week, like a huge, like bigger, like smaller than an 18-wheeler, but bigger than a U-Haul. So
Like
that
a
was
tank,
Good
and you just drove over the houses of people you didn't like, so you cleaned up the place. Is that it?
no. I had to move some things, and that was the only thing available, so I drove it.
I could see Lulu driving a tank.
Yeah, tanking.
Probably. I could see myself driving a tank, definitely.
And
That would be fun.
crushing the houses of people she doesn't like.
That's it, Lulu. We're gonna start a car.
Nah, no.
There you
And
go.
I was so scared to bump into anything. I was like, like the chair had like the hydraulic, so every bump goes, and I go up there with the chair, but it was fun. Yeah, it felt like a roller coaster.
Maybe one day we'll see Lulu on that show, Cops.
The cops are to a tank. Can you believe that?
Man, they watch me. I swear to God, I was surrounded today. Like I could see them in like the mirrors. Like they're emptying the road for me somehow. They're like, they know maybe she doesn't know how to drive it that well. Like empty out the road, But yeah, I had that feeling today.
Make way. Here comes Lulu.
No, but I like routed my route. I knew like, okay, I'm gonna stay in the middle lane because whatever branching happens, this one's gonna stay solid all the way through. So I don't have to do too many lane changes. So I started from the beginning, so I didn't have to, like just steady, till I got there. It was like, my God, but I swear to God, it was such a relief. That I gave it back unscathed. It's a responsibility, man, when you borrow something from somebody, especially if it's something really expensive. Yeah, I was glad
Absolutely.
I was so glad to, give it back.
Yeah.
Yeah.
Next time, ask for a Ferrari. You're gonna have more fun driving it.
Yeah, well, I needed to move something, so yeah.
I think we
Next
have
time.
Big Bad Ben's aboard.
Next time.
Mr.
Yeah, cool.
Here. Everybody, live chat is open. If you have any questions, comments for the cast, please do so.
I got a question for you.
Uh-oh.
Okay. Uh-oh.
How the hell are you?
Good.
How you doing,
This is-
Mike, Gerald, Phil, Nawal?
Second
It's good to see
question
you all.
is second question. What's the winning
Lulu,
number
Lulu.
of the,
Oh, I'm
what's
sorry,
the
Lulu.
winning what's the winning number of the this week's lottery?
14, 38, 9. I'm just kidding.
27.
Well, I got
43.
I got my numbers played tonight for the Lotto Max. It's 25 million, so we'll see.
Dang. I'm coming to your place if you win.
I'm sure a lot of people will be showing up.
There you
the,
go.
the beer's on you.
Yeah.
Is the Powerball like nationwide or is it just state thing? It's a state
No,
thing.
it's nation. It's
It's
nationwide.
nation. Okay.
But the states
Yeah.
have their own individual lotteries too, don't they?
Yeah, we have Lotterio, which is basically, I believe, just for Ontario. And there was Super 7. We used to have Super 7. Now they made it into, what is it? They have a cash for life draw. $1,000 a day for life.
Well, that'd be nice.
They could have, yeah, that would be a nice one. I'd be happy with $1,000 a day, no doubt. But the thing in Canada is when you win, you don't get taxed. In the
Oh, that's
US, you get
nice.
Taxed.
Are you
there's
serious?
No tax on our
They
wins.
don't tax.
Yeah.
Yeah.
Not
It's
not
straight
not in
winnings.
Canada. You get your straight winnings in Canada. In the US, you get taxed. So if you say win like 100 million in the US, you might see half of that after taxes.
Right. And if you don't claim it, they'll come after you.
But damn right they will. Oh yeah.
I wonder if you invest it right away, you don't have to pay tax if you invest it. Like, you don't let there's a calendar cycle. If it doesn't pass that, then they tax you on it.
I
Maybe
don't
there's
know.
some kind of loophole. I don't know.
If they're
I don't
willing
know
to give
here,
me
'cause-
50 million and I give them 50 million, I'll take that deal.
But did
Now-
you guys know that Facebook, Facebook is in trouble right now for $1 trillion lawsuit
Really?
for messing up with the brain of teenagers. Some states are going after him for trillions of dollars, which is the valuation of his own company. So
Oh,
if he
because of the
loses-
algorithm?
Yeah, because he messes with the brain of teenagers.
Yeah, dude, that guy can literally rig an election if he wanted to.
Oh, they
Yeah,
all can. Every social media platform could. Very easily.
Yeah, no, that's definitely true. But I mean, Facebook has a unique way of like being able to indoctrinate people with their.
That's true.
you know.
That's true.
Yeah, you're absolutely right. Every platform has the ability to do it.
Yeah.
Oh shit,
Oh, you lost your webcam.
my
Oh,
bad. I
shit.
stepped on my wire.
That's perfect timing, though, Ben. You're like, yeah, every platform could do it. Ah, shit.
Sorry.
great. Gotta have
Yeah, I
fun
know.
with it, right? Life's short.
So let's get into things here. Philip, you got something for us tonight?
Yeah, I mean it's pretty interesting too. So, it's kind of deductive. So it's not like hypothetical stuff, or it's all deductive. I'm just gonna start. I got a lot of stuff to share, but I'm gonna start by saying that you remember the free fall experiment I've been talking about recently, but that I did last year.
Oh, where you dropped your balls.
Yeah. No, I'm not a man anymore, so.
I'm
he's-
losing it
no,
in the background
no.
when you said that, man.
No,
You dropped
he's
it
a
right
real
off a
man
wall?
now.
What?
He's a real man now.
Yeah.
Hey,
I'm
when
sorry, I
you can drop
couldn't
them
help
off
myself.
a wall, when you can drop them off a wall, dude, yeah, there's a lot of man going on there, okay? I'm just saying.
Yeah.
He put his
But
balls
then-
to the wall. Remember that song?
That's an awesome song.
Okay, sorry, Philip.
Yeah.
Yeah, my bad, Phil.
No problem. So I collected the statistics, but I did spend some time trying to figure out the exact equations to explain the deceleration of the magnetic ball, and I got it. I think I'm pretty sure I got it, but it's not like essential. That it's just like extra curriculum. I'm just trying to figure it out because it's cool stuff to know. But I did, by the way, I did figure out the exact mathematics for the MHD vortex, the grinder, and the spinning wheel that I've shown a couple of weeks ago. The guy spinning a wheel that is very light. I have the exact maths for that, and it's pretty
Woohoo!
awesome. Yeah, it's pretty awesome, and it's all that it has all about the stealth propulsion, and the stealth propulsion is spot on. I know exactly what's going on, and I don't invent anything. It's all mainstream. It's all a recast of gravitomagnetism and the Lorentz force. And I did the calculation. It's spot on. It's pretty cool, and the mainstream is very misleading, but for the gravitomagnetic field of the Earth. But it's very simple to figure out, and it's very easy, and everything works. It explains all my experiments, and I'm really happy. But to go back to the free fall experiment, I did try to get the exact maths. I'm pretty sure I got the exact math right, but you can see the blue triangle here. That's the top speed that the magnetic ball can have, and in my experiment, the height was just 4 meters. But if the height would be higher, then the magnetic ball would have reached the top speed and then slow down. Actually, slow down a little bit. Well, not slow down, but I mean the acceleration would reduce. And But this is the peak, 4 meters, and then the magnetic ball stops. The acceleration is kind of diverging here. I got the acceleration graph here. Actually, instead of saying anything, I'll show you the graph. This is the velocity versus y position. This is the acceleration. You can see the blue line is the acceleration of the magnetic ball. So it starts at 9.8, the standard gravity, and the acceleration can reduce to all the way to 2 meters a second. So that's my projection here. So the acceleration lowers. If you look at the jerk, which is the derivative of the acceleration, then you get this peak, which is 2 meters. So the maximum, so the corresponds to the maximum speed of 2 meters. So yeah, it's pretty amazing. If I would have let the magnetic ball fall down from a higher height, then I would have gotten really really interesting results. But this is extracurriculum stuff, just nice to know subject matters. But this is the actual the vortex in the MHD vortex, the grinder in green, and the steel wheel in orange. It all follows the same fractional weight change. So anyway, everything is spot on in my math, so I'm really really happy about that. By the way, if you want to measure the acceleration of the sun, because the gravitational field of the sun can be measured very easily on the surface of the Earth. The iPhone has a gravimeter on it. There's an application to measure there's a gravimeter on the phone you can use. So You install the right application, you use it, and then you if you put your iPhone flat on a spinning plate like this one, and turn it around, then you're gonna measure a fluctuation in the gravitational acceleration, as you can see in the red line, the red and the green line here. These are the y and the x axis. The blue line is the z axis. So the z axis doesn't change because the iPhone is flat on the spinning plate. But what changes is the y and the x gravitational acceleration, and this is exactly what is measured here in the red and the green um, gravitoelectric or gravity acceleration amplitudes. So, and this corresponds exactly to the acceleration of the sun on the surface of the Earth. So, it's nice to know stuff. I was trying to measure something else, but I figured out that that was the acceleration of the sun on the surface of the Earth.
Does it matter which way you rotate it, the spinning plate?
No, it
No.
doesn't matter. You're just gonna have a reverse graphic here, but it's the if you measure the delta acceleration, then it corresponds exactly to the amplitude of the acceleration of the sun on the surface of the Earth. So it's nice to know stuff, and this is now the cool stuff. Like I was saying last week, I wanted to apply to Lockheed Martin, and this is exactly what I did. I applied as a supplier for the tractor beam, the electromagnetic tractor beam that can generate 3,000 newtons per kilowatts of pull or push. And if you use a radio wave, a very dense radio wave, then it can travel through matter. So it's more convenient to have an electromagnetic wave not reflected and that is being absorbed by the matter, including metal, because projectiles are made out of metal in general. So you want to be able to deflect projectiles, push them back, or deflect them at high speed. So if you use a RF wave, a very dense radio wave, then you can. There's a way to apply a force on it, and this is what I propose to Lockheed Martin. The scale is logarithmic here; it's not linear. So the difference is more important than what you see. And same thing with the stealth propulsion. The stealth propulsion I'm proposing, it offers like up to something around 10,000 Newton per kilowatts of power, and it beats the competition, the DARPA pump and the Yamato one, the Hall thruster and all that. So
Well,
it beats them all.
You're on the ball when it comes to using radio frequency, because Commonwealth Fusion is using that in their fusion reactor. So it's an interesting concept.
Yeah, exactly. And regarding the stealth propulsion, I could use more energetic stuff like gamma rays and things like that, but it's not worth it. You can use the same thing. You can have the same net energy by using a lower frequency electromagnetic wave, but of higher density. So you're gonna have the same energy per cubic meter. So it's exactly the same thing. It's easier to produce and it's less dangerous, and it goes through matter easily. So regarding the stealth propulsion, that's like I was saying before the show starts. It all has to do, and I was saying last week, it has to do with the Lorentz force and the gravitomagnetic field and things like that. So I don't invent anything. There's nothing exotic. So and the mats are spot on. They're perfect mats. There's nothing hypothetical or anything like that. Everything is deducted. So I'm really happy about that. I'm waiting for the feedback from Lockheed Martin. And if you wonder why I am stubborn with Lockheed Martin, look at their world revenue compared to the second best defense company out there. They have almost the double of the revenue of Boeing. So they have a lot of cash, so they're a lot more interesting to work with. So yeah, that's the stuff I want to share tonight. And also next week I have a very important meeting with a top cybersecurity company in my own hometown in Hall or Gatineau Hall, and I'm really happy about that. And I'm gonna work my posterior up this weekend to get the presentation ready and the software ready and all that. So who knows, man?
Nice.
Next week I might stop being so poor and I
Well,
might
good for
finally.
you, Phil. That rocks. And if you do stop becoming so poor, I want a poutine.
Do you think
You'll
your
have it.
your tractor beam could stop an orb from the sky? Like, would it like
Yeah,
could it be able to?
in theory, it can stop anything because it's a radio frequency wave. It can go through everything, and all you have to do is increase the energy density of the radio frequency wave to have a strong net energy, and
Well,
and
if you're able to use plasma and manipulate it, you'd be able to capture it, use it as energy, right? So if somebody threw an orb at you, so to speak, and your system is dynamical enough to absorb that, you can actually use that orb, not as an orb, but as absorbing it as energy, right?
Imagine if it can encase it, and then he lowers the energy, and it could just drag it with it.
yeah,
Create
like the Star
an-
Trek tractor beam, yeah, exactly
something
the
like
same
that.
thing, yeah.
Or maybe you can
Yeah.
structure plasma with the field cavitation effect or something, like an
You
interference.
capture it through spin, right? So
Yeah.
Yeah, and they do for the mathematician out there. It's the power in theory. The power it generates can be in the force can be infinite, but it's limited to the hardware we have. So, but the theory is there. So
Is there
that's
like
really
a
cool.
certain threshold of power before this effect happens? Like you have to have a certain amount of energy before
Yeah.
you can see
Clearly,
anything?
you have to beat the thrusters of the orb.
Mm.
You have to have a stronger force than the force of the orbs.
or
But
at least the
Oh.
same potential energy as the orb in order to resonate with it so that you can capture it and absorb it. Am I correct in saying so, Phil, with your tractor beam?
Yeah, the potential energy, that's the gravitational potential. Yeah, exactly. So so you need the volumetric force, like a Newton per cubic meter. So I need to make the calculation, but it's proportional to the force per cubic meter. So
Interesting.
but yeah, and the other thing again with my um, proprietary modulation, I can generate as much as power or force as I want. So it's pretty amazing because the power is just the time differential, and the force is the the space differential of the energy. So they're
Yeah, but
basically the same thing.
remember, they're gonna put these on like fighter jets, so it's still gonna have already speed to catch up with this. And in addition,
Yeah.
with your thing, then it has like you understand, they could track it. It's not just from the ground that, it's used.
Yeah,
Yeah.
I have a
exactly.
different take on orbs and being able to absorb them. You do it through thermal radiation, thermal emission, basically.
Yeah, you're robbing them of their energy.
Yeah, it's like I don't know. It's like the origin of gravity is really from entropy, and if you could capture that,
Yeah.
then you can negate gravity. How do you capture entropy? Well, you literally
Yeah. That's
switch.
what you were talking about. Yeah,
You'd
you
have
can
to reverse
definitely
it
do
somehow,
that.
right?
Well,
Yeah,
you don't reverse it. You can't reverse entropy. What you have to
cancel
do,
it. You
You
cancel it.
cancel it out.
yeah, by switching
Okay.
so fast that you absorb the ambient heat in that area, turning it into potential, and then using it for whichever way you're going to use it.
Interesting.
Yeah, it's part of my paper. I'm going to release it soon.
Gerald, does that have anything to do with the effect that we see in like Bedini systems where you have to switch it real fast before the electricity comes on?
Absolutely. Bedini
Okay.
was not telling the full truth of his system. And
Well,
he
I'm just
knew
wondering-
it too. He freaking knew it, man.
He knew it.
Oh,
Well, I'm
yeah,
wondering
he knew
because
it.
there are fractals that we see with different effects in these kinds of unique systems. So I'm just wondering if there's a connection there.
Well, fractals are kind of like a key code, but they're more like a pathway that energy takes that nobody expects to look at. Like
Oh,
take a
so like
wire, for instance.
the
Go
Eric
ahead.
Dollard experiments with the lightning on the wood.
Some similar, but
He
not
would, like,
quite.
I think he was discharging pure potential onto like different mediums so you can see the path that it wants to take. And it
Yeah,
would,
well, what
like,
he'd do is he'd charge the potential onto the medium he was using, and then he'd
Mhm.
ground it out in a really quick spark, right? And then it
Okay.
would fractal.
yeah, and it would
from
display
point-
these like geometric patterns that
Yeah.
were really crazy.
Yeah. But there's a way of capturing energy through geometrical patterns. If you
Right.
understand how the energy flows and what
That makes
energy
sense.
you're trying to capture, because there's more than one type. There's time energy, there's just energy, like your watts between voltage and amps. There's negative energy, which is basically like a mirror image of what you would use, say, in your wall. So if there's 120 plus, there's 120 negative, but how you capture that negative is important. It's just all part of my theory. Sorry.
What if a parallel world uses
That's
that?
fascinating.
What if a parallel world? Yeah, that uses the negative energy. We use the,
And then they use the
positives, and then we
positive and
use-
the
Yeah.
and it's like
Like a
inverse.
mirrored universe or
Yeah.
a mirrored dimension.
Yeah.
Yeah, that's possible.
Interesting.
I mean, they say there's 12 dimensions, and so it's 12 positive, 12 negative, but you can't visit every one of them because some of them are beyond human existence. But that's essentially what they are.
It's density levels.
Yeah,
Think of it like
yeah.
that. Like it's density.
Oh.
You know,
You couldn't
Density
exist
of
in a high
energy.
density.
I mean, you have the rainbow that splits. Like it's one, but it splits into 7. So you still have different, densities to reflect that color of.
Absolutely.
Interesting.
And we can only live at the density that our bodies and our consciousness can retain, right? So if you were to go to a higher density, your body's what? Is it going to deteriorate? Is your conscious going to be able to actually be held to your body? Like different dimensions do different things.
No, I would think it would be like it refines itself to the core and sheds everything else. So there's still preservation of a starting point.
Yeah. Yeah. What if, here's a question for you, like the starting point or the origin of the universe, there would be no time, right? Zero time. It would be like the null zone, like there's nothing there. So what if you could create a system that creates that point? That would be like creating a 0 point system, right? But from that point, everything that's outside of you would be filled with the energy from that single point where it started.
Yeah, Gerald, you made a good point there. The point of no time or the universal grounding point. That's Eric Dollard was talking about that, and he believes Tesla was onto that.
Yes, he was. He was, through a geometrical coil nobody really knows he ever built, because he started playing with geometry before he quit.
Yeah. So the theory is, like the way Eric Dollard says, he goes, if you hold like a pen in your hand, right? And you decide to jump off the train, this pen has got a lot of energy stored in it. So if you throw this pen off the train, this pen's going to make a huge explosion because there's a huge amount of potential energy there. So if you're able to find your universal ground or zero, all that pen has so much energy in it, it would probably power the entire planet for probably the next 50 years. Because that's how much energy would be in that.
Exactly. If you could find your 0 point of gravity, your null zone, all the energy is going to flow to it. It's like a mountaintop with water flowing from the top all the way to the valley down below, right? So what you do is you wouldn't capture that water down below in the valley. You capture the flow of the water from the hill to the bottom. And that's
interesting. So Gerald, in that imagery, would you imagine, instead of time being like like a linear line from start to finish, would it be more imagined as like this null zone with like waves coming out in a 360-degree?
Absolutely.
Interesting.
Time's not linear.
Yeah.
Not at all. We experience it as linear because our lifespan is what? It's a spit in a bucket. 120 years at max.
Well,
if you think about it,
time dilation is proportional to the energy density, because if you go in a black hole, for example, time will stop. I mean, for an external observer, if you're in the middle of nowhere, then time will run much faster. So it has to do with the energy density.
I think you're correct, but time's funny. It isn't just one thing. There's 3 different types of energy in time. So 3 time energies. That's what I found from the experience that I've got. I'm going to release this all, man. I'm telling you.
You know what? The way my take is, especially when it comes to say like time travel or time dilation, is being able to ground yourself to the 0 point in time, or because we're in relative motion right now. We're traveling over 200,000 miles per hour around the sun. It takes 1 year for the Earth to make one orbit around the sun. And we're also traveling at hundreds of thousands of kilometers an hour through open space or in our own galaxy. But if you're able to grab an anchor and drop the anchor, guess what?
Time pauses for you.
Wow, interesting.
That's time stops.
Our galaxy is moving towards Andromeda. So at some point they're gonna merge.
Collide.
It doesn't matter if it's moving where it's gonna go. It's the fact is, if you're able to drop that anchor and stop you, your time now stands still while everybody else's is relative.
Okay, but energy doesn't stand still. So that energy, when you stop time, when you're sitting at that point, it's got to flow
that's your free
somewhere.
energy. That's your free energy.
Yes, and you can use it for electrical, or because it's time energy and you yourself are affected by time, if that time energy flowed into you, it would reduce the time that you have living where you are. In other words, not reduce, it would increase. How? By filling every cell of your body with energy that you're constantly losing as you're living life. But if it refills that energy back to square one, and then you were to shut your system off, you're literally pause time for you, and you're starting right back all your cells at square one. Does that make sense?
Yeah,
That
that makes total
does.
sense.
So it's not like you're growing younger, but your body is filling with so much energy that it repairs itself so fast, you're actually pausing your aging.
That's why it's called anti-aging, right? Because you're not making yourself younger, you're just slowing down and stopping the aging process.
Well, your cells
And
will
repairing it. But
back to like they'll repair themselves, right? And
I
you'll
love that term. They will retard back to a better state. So don't go full
Exactly.
retard, just go former retard.
Yeah, nobody goes full retard, right? Maybe half retard, that's okay, but you know. You see that movie? I loved it.
Oh yeah. Oh yeah. Oh yeah.
But yeah, that makes total sense. So I think the real key point, what Tesla was trying to accomplish, was find that universal grounding point. When
Yep.
you're able to do that, then you can harness all the free energy you want.
Absolutely.
And
Tesla-
I think that
Tesla
Sorry.
was Tesla said I saw somewhere Tesla was measured something 50 times the speed of light.
Yep. He actually
I
he
do
achieved
recall that.
yeah, that's the heaviside effect. That's the electrostatic potential.
Do you guys remember
Okay.
in his book? What the heck was the name of it? I can't remember. One of his books, he talks about how time is. He saw the past, the future, and the present all at once.
Oh, connecting
Yeah.
to source or
He actually
lucid
achieved.
dreaming?
I would say a little more than that, dude. I think he achieved not only anti-gravity but time travel. It's the same system that Otis T. Carr was claiming that he built. But
Yeah, I think
everything
once you
Tesla was
achieve
working
some kind
toward-
of
Once you have that bubble,
electrogravitic effect, you have
the
the ability
bubble.
to manipulate time with the right.
Yeah,
you can't manipulate.
I personally think that this time travel, time dilation, your consciousness is a part of this equation.
Yep, because your consciousness
Exactly.
really attaches to plasma, and plasma is one of the key ways of traveling through time.
Well, the plasma, once you have the plasma sheath, that plasma bubble, that is your warp bubble, that is your conscious bubble, that's your time space bubble, all in one, right? So it's everything.
It's not a sheath though. It has to be a bubble inside a bubble with a sheath in between. A sheath is more like
Exactly, Gerald. And
Yeah.
then another one inside of that, and another one inside of that.
I don't know about that one.
Well, it's a displacement of space time, right? You're creating a force
There's a
field around you.
displacement
So
current between your time, like the time that you're in, where the 0 point is, and then the outside time, so regular time that you're used to experiencing. Does that make sense? And the sheath is in between that.
Exactly.
Energy. Yeah.
And then the reason for the other two is for the place that you intend to go successfully, and that's why you need 4 to correlate your travel and your bubble properly.
I disagree, Bernie, but I only disagree because of experiments.
Hey, Mike, can you share my screen?
yeah, I'll do that. I'm gonna
there's
scoot
some-
out for a quick smoke. I'll be right back.
There's an experiment called Kaznachkiv. It's
Mirrors?
KAZNACHEYEV-KOZYREV mirror.
Yeah, the mirror, the
it's-
Kozias mirror, really good
well,
Russian mirror.
Yeah, so
Find
that
that
mirror, like whoever went into that, aluminum, coil, said that they experienced seeing the past, the present, and the future. So it has something to do with the light reflections that we see. Maybe.
Did they experience it like at the same time, or was it like a different aspects?
Gotta read into the
I don't know. I
experiments.
just understood that.
There's extensive work. He's a very famous Soviet scientist that was quite suppressed and classified, and then after the fall of the Soviet Union, his work came out like several others.
So light is directly correlated with time. You can't have one without the other. They're intertwined.
Yeah, the energy density. Check this out, by the way. The scientists that were able to create matter with virtual particles from empty space. It's pretty cool. This is from this week actually, so it's very recent. These Brookhaven National Laboratory, Stony Brook University, blah blah blah. So yeah, it's pretty awesome. Like they're able to create matter from empty, like a void, empty space.
Yep, I know exactly what you're talking about.
Indeed. Right?
Yeah.
Like, I know exactly. Wink, wink, nod, nod.
Well, let's just say room temperature fusion reactor is 100% possible. 100%. I
Been
would
there,
swear on
done
the
that.
Bible to it.
Been there, done that. We need to still link together there, Gerald, and combine them
And
together.
what does a fusion reactor do? It pulls the energy out of what? Your environment. And if there's some sort of like, I don't know, particle sitting in your environment, let's say a smoker, right? Smoke cigarettes in your room and it's all over the walls. You would be able to literally pull that nicotine and tar right out of the walls, right out of the environment, and drop it on whatever plane of 0 point you're using. Literally, it's part of the whole system.
Absolutely, Gerald. Absolutely. And so that's the first magnitude of it. The second magnitude is that you're then able to also pull the radiation, the waves, like light waves, sound waves, and electrical, and then they turn into particles of phonons, photons, and electrons in this process as well on that same plane.
Yes, but no.
That's the magic of turning particles matter from virtual quote unquote particles to physical matter.
Yeah, they call it virtual, but it's already there.
As a wave. And then we turn it into a particle. Wave particle duality. When you understand it, you get it.
I understand what you're trying to say. Absolutely.
Exactly. Just not in my spectrum autistic manner, right? So
it's all good, Bernie. We all need a weekend.
Do y'all think that
it's
energy?
Weekend at Bernie's right now, y'all in the lab.
Energy really is the transition of electrons from one element to another, and that's what gives the energy.
For elements, yes, but there's also phonons and photons that are in that same reaction and atom to atom energy transfer, but mostly electrons in our usage in energy.
Well, it's all part of it. You can't just get away with using electrons or just photons or
exactly.
You need literally sound, light, and vibration in order to have a fusion reaction occur. It was all part of Moses's system when he was making manna.
Well said, Gerald. Continue giving away God's secrets because it is that technology.
Oh, I ain't giving it away. You can hear what happens, but I ain't gonna tell you how. Just kidding.
But no, that's the whole point, though, is what you're saying is accurate, and it's sharing that ancient God level technology and understanding it, and that those that don't get it or don't understand this history, that it's by design, that they just consciously can't comprehend the technology of working on this level of density of science.
Look, I love the United States. I think it was at one point the best country in the world. And I think that there's a lot of brilliant people in the United States. I also think that your government's lying. They've had fusion reactors for over 40 to 60 years.
That their government is lying.
There you go. And I'm not even sure if Canada doesn't have fusion reactors at this point. But it definitely, that technology has existed for a long time. And the fact that the governments of the world are putting hundreds of millions, billions even, into building this technology that they already have makes me wonder where all that money is really going.
Right? Or they're just literally a bunch of idiots, Gerald, and that like you and me have like figured out how to actually do it with like pickle jars and like alternators and coils and shit in our backyards, and that's what pisses them off. I don't know. One or the other.
You know,
Well-
there was a fusion reactor named ITRA, and then it disappeared from anything searchable. But they talked about it and they explained how it works and how the plasma rotates like in like deformation.
Yep.
Like if you put a bunch of D's next to each other, that would be the how it would look like. It was called ITRA,
Interesting.
I remember
and then
that.
it disappeared.
Yep.
And so
You're talking about ITER, right? Or
Oh, Ital.
it
Itar.
Itra. It was called Itra. ITH maybe. But I don't hear anything about it anymore. And that's a fusion reactor.
ITER.
yeah. Well, see, there you go. They're
Good call. Good call. I forgot about that one.
they figured stuff out and they're not talking about it because they're siphoning as much money as possible in order to build these new ones, which probably don't even cost 1/10 of what they're pulling out of everybody. It's such a
lot of
joke,
the-
man.
A lot of these technologies are all locked away in private corporations
Yeah,
and don't have any oversight by any government faction. That's what's going on. Because I know it because I've worked in one of those facilities.
see, there
Yeah,
you
most
go.
of the governments don't even know about them. Maybe
That's right. It's
maybe
like a trade
Exactly.
secret to a company. It's like you
Reddit.
have a trade secret to a company.
Mm.
You're not going to tell the government. You're keeping it to yourself closely.
Well,
You know what I mean?
what if it's a generational
True.
cycle? And like, okay, we have a lot of people on planet Earth. If we're gonna, not give a chance for inventors, even if they're reinventing something that, somebody invented and was held, but you've got a lot of, people that need jobs, need to, have a purpose of going to
Lulu, you're
school and,
bang on every time.
you
And
know,
that's the thing everyone needs to be doing. And what we've all done here, but what we need to focus on, right, is rebuilding all of the ones that have been published where people have been murdered or died or suppressed, like the Bendini, like Stanley Myers. And it's that the patents on those have now expired and that everyone can freely build them. And it's just a matter of building them, using them, and showing people that it's real, and then industrializing it for the actual economy and
Well,
for
that's what they won't let
people.
you do is industrialize it, Bernie.
Well, so it's
Reason why-
industrialize it on a localized level.
Yeah, I
That's what
get
it's
that.
about now. And
Yeah.
it's
yeah,
that
and
there's
even if
gonna
they're
be
not,
forced
the patent's
into
not
that now.
expired, there's no law against recreating something. There's
no,
no
you
law
can
against building
recreate it
yourself
for
as long as you
yourself.
don't monetize it.
Yeah,
Of
that's
course,
the thing.
that's step one, Gerald, and I'm pretty sure you're well advanced over that.
Yeah, I'm a little bit higher. Yeah, you could say that. I took time off because I've been building a couple of things that I don't want to share willy nilly, and when I do share it, it's gonna blow people's minds. There are
It's
people out
about
there
it's
that were.
about it's about what exactly?
Nice
Well,
try
that'd be
there,
giving away
Phil.
the
But,
goose, man.
Gerald, I need my mind blown, so you should call me privately sometime, and I will listen, and we'll do it together. Because I got a couple I've done that I also haven't shown that.
Yeah,
I
but,
will
but,
show you.
but both of you guys talk when you sleep. So whatever girl you're with, she might be a spy. Hey, talking about spy.
I wondered why Phil was trying to get on my phone when we met in person.
There you go.
He listens while I sleep and talk, eh?
He's just hearing my cat. purr. That's all he's hearing, man. I don't talk.
No,
about
but
it.
seriously, did you know that Newton, Isaac Newton, that guy F equals ma, he was in competition with Leibniz, the other guy that was inventing calculus, and Newton had some money and he hired the wife of Leibniz to spy
Oh my
on his
God.
work. To spy on his work and steal his work.
And he
I
paid her
remember
with a
that.
little
Yeah.
extra 2 inches that Leibniz just didn't have.
That's nasty, though, eh? You can't trust anyone. Damn it.
Even back then, man, it
You
was
guys are
like that. Imagine.
horrible. You guys have dirty minds. You really do.
We're just kidding, Lulu. Come on, we're
I'm
playing.
just listening in the background here. I'm just innocent
He was
bystander.
just covering up because it was the wife that committed the sin in that one.
Right?
So they say. There you go. So they
Yeah,
say.
so they say. Yeah. Who ate the
I wonder if
apple?
that's how he
I'm
discovered
just
gravity.
That's how he discovered gravity.
Yeah.
You know, I still have my version of the Adam and Eve story, and and the apple and all of that stuff, and it exonerates Eve 100% from all wrongdoing. It was Adam's fault. He had the conversation with God, but he thought he was so all that he didn't share it with Eve. How would she know? She picked the apple and she bit it because he thought he was God's friend and she was lesser than him, so he didn't tell her. Do you see, when two partners don't share information,
But
something
there's
bad
I
happens?
never bought the
Communication.
There you
official
go. That's the
narrative,
Adam and Eve
anyways.
story for
Communication.
you.
a
I
much
never
more
bought the official
twisted-
narrative. We
She
always
she,
blame
she
the
never
woman.
received the memo. That's the
There's a much
problem.
more twisted version to that, and it's sick. Lord, forgive me, and please, you guys out there, forgive me. But Eve was listening to the trouser snake. Okay. I'm
Not
sorry,
true.
I had
Not
to
true.
say it.
Not true. Eve was bored because he was with God. Like, I don't know what they were doing. Like she's all by herself. What did you
Hey, look,
expect? She needed somebody
I'm
to
just
talk
playing.
to. There you go.
I really don't know. Who knows?
It's fun. It's
all
just fun to
Yeah, you're right.
Who knows? Exactly. Who knows?
I wasn't there personally, but
Yeah, I'm just taking today's social, dilemmas and decision making and things.
Yeah.
It's the miscommunication. That's what causes problems.
You're
Miscommunication.
right. You're right. It's
So,
all about communication in a relationship, and our government's lying to us. Thus, we are the abused partners in this relationship.
Yeah,
It's
but
time for a divorce.
Yeah.
It's time for a divorce.
Absolutely.
If you guys could travel back in time, what time would you want to travel back to? What would you want to see most?
I mean, I wouldn't want to try. I think right now is the perfect time because we
I
have
like
a
Phil's
gravimeter.
answer, and then
We
I
have
would
a
say Atlantis halfway through, and then I would also say the time when humans used to ride around on dinosaurs.
Yeah,
Okay.
you're not gonna say that if dinosaurs eat your head,
and plus you wouldn't be able
I
to
seen
breathe.
that.
We had saddles.
You guys ever watched the Flintstones? They used to write.
Fred and Barney.
They did.
And Barney and my dad's Fred, and we watched the Flintstones as a kid.
Do you know the
It's
twisted
dramatically-
conspiracy theory behind the Flintstones?
No.
What is
How
it?
it's supposedly a post-apocalyptic world,
Oh yeah.
and it exists at the same time as the Jetsons, who live in the sky.
Exactly.
Because the
all
I like the
simultaneous.
Jetsons. I like the
Yeah, because they had a few shows where they cross-linked the two shows together.
Oh yeah. Interesting.
Yeah, I still eat Fruity Pebbles. I mean, they're really good.
Oh, they're the best.
yeah. So
Anytime I come to America, I
Flintstones.
order Fruity Pebbles. They're so sugary and sweet. They don't sell them in
absolutely, yeah,
Canada.
they're perfect.
Yeah. They don't sell them in Canada. Wow. I wouldn't. That doesn't surprise me though. We got a lot of stuff that other countries don't
We're
like to
very
sell.
communist up here.
Yeah, here we like a lot of food dyes. We like
Chinese. Chinese blocked the pebbles, from Canada. So
Well, I think it was the liberals, but I guess that's one and the same. All right, no more politics. Back to science.
Yeah, exactly. So, Gerald, it's been a while since you've been on. Maybe kind of give us an overview of what you've been up to in the last while. Mr. G.
Oh,
G-Man.
sorry. Were you asking me something? I had somebody talking in my ear. They're asking me something.
Oh, okay. Yeah, just kind of give us an update what you've been working on. It's been a while since you've been on.
I don't wanna.
You don't wanna?
I mean, you don't have to.
Okay.
No, I'm just kidding. I'm kidding. I'm working on solar stuff right now. I found a way to bypass certain things that how do I put that without giving away the goose, Mike?
Yeah, that's kind of a hard thing to do.
Right? I know. So
bypass the red tape. How's that?
Yes, there you go. I found a way of bypassing red tape when it comes to installing solar on your house. So up to 5,500 watts could be supplied to your home without paying the additional, what is it, $15,000 for a structural engineer and another $12,000 for an electrical engineer to sign off on. I think it's that much. I could be wrong. But
sounds about right for legal regulations on it. It's ridiculous.
In order to get solar installed on your roof. Well, I bypass all that red tape and legally. So I'm gonna show that this week online. Probably do it live. I'll probably do it on Mike's channel. Like I'm gonna do it on mine.
The funny part is, Gerald. The funny part is, Gerald, that bylaw, okay, actually goes for when you build a deck on your house.
Yeah. Oh, really? So you can
you can build solar decks. I see what you're saying there, Mike. I like that.
Is that what
so when you build a deck on your house, if it's a floating deck that's sitting on its own foundation and not attached to the house, you bypass some of the laws.
Oh, well, that's
so then cool. You build the roof on your deck and you put the solar panels on the roof of the deck and you bypass the laws. And that's what he's saying.
You can't do that because it's an exterior building.
But it's a deck, so you can.
Not if it's got a roof, you can't.
So that's why it's not a roof; it's a mezzanine style.
Maybe
it has to be.
See, now you're getting how to. It's the Mexican way of working. Past permits.
But anyways, it's a very cool thing what Gerald's doing, and I think that would be a game changer if somebody's considered, hooking up solar panels to the house, but don't want to go through all the red tape and all the regulations that go with it. Gerald's found a way around all that.
And reducing the cost.
We actually kind of just did it all together with the deck thing, and that you don't have a roof, but you have like panel roofing that isn't a roof, but it's your panels, so you're good.
I mean, what if you put it on the ground? Like just build a frame and put it on the ground.
Oh, sure you can, but you don't get the same amount of
solar exposure and time, and then you're also using up ground space.
With my tractor beam, I can use the solar panel and amplify the power and convert it back into electricity.
That sounds great, Phil. Beam me up when you have your Starship, and I would love to be on the tractor beam.
Little update on the EV world. There's a couple of companies. I believe one's in Germany. They're now going to start implementing solar panels right into the vehicle itself.
Yeah, that's kind of cool.
And on the roof.
But all it does is give you a slight extension, though, right?
Slight extension, but if you're sitting at a rest and you're not moving, it's still charging your batteries.
So charges it. Yeah, right. That's good.
So after 8 hours of sitting out in the sunlight, you might give you enough charge just to get home, right?
Well, see,
and you're not plugging into anything.
I've given this little part away
for camping. That's amazing.
And I don't understand why EVs don't do this. And this would come in handy for a German EV with solar. Split your battery bank. Let's say, that you have 100 amp hours.
Because, Gerald, you're exposing certain electrical engineering things that aren't allowed to be made efficient because it's not free energy. It's just actually efficiently engineering, and that's why solar panels can only be 23% efficient, and other certain things like battery banks and how they're wired and how they wear out and how they charge and how they're used on things, and rectifying from AC to DC.
I've already fixed that problem.
I know you have. Of course you have.
Everybody has to know it, Bernie. I'm telling you.
So share it. I'll shut up.
If you take 2 battery banks and you take a battery bank and you split it, you charge one half of the battery bank while you're using the other, and you just flip it. So the one you just finished charging, you start using. The one that you're not using your target. And if you do the calculation correctly, you can literally ride with never having to plug in.
So I literally just read about an article about a solar panel that was getting 120. There's a solar panel that was developed with metamaterial recently that claimed 120% efficiency. So if that's true, that's a huge step.
Oh, I believe it.
It'll be an act of God for them to actually release something like that.
Right, well, that's a different.
Well, that's why we're all here talking about it and developing it ourselves.
Exactly, Bernie. Like we got to talk about it, and if it's true, look into it and all that stuff. But
you guys want
test it.
You want free transportation?
But I don't know how we develop metamaterial. That will require
That's why I'm here. That's my specialty, literally. From aerogels to your room temperature solar superconductors to different types of polarized particles and charged particles, and I can't give away all the details.
I'm doing it. I guess Bernie, I'm doing alchemy too with my power cells.
Yeah, you guys are both doing alchemy to a certain extent, right?
All I'm doing is alchemy.
Well, I mean, at least to a certain extent, his power cells are.
So I'm not going to tell how I do it, but I discovered a way of increasing the energy density of a graphite plate up to 50 times.
Oh, yeah, he did.
Oh,
nice.
So I'm going to be doing it this weekend. I've got all the materials to do it, and I'm going to try it and see what happens and build a new cell with it. Also got some.
And on that note, Mike is not suicidal. He's very happy, and if he disappears, that's exactly why. So 50 times X on that graphite plate. All right.
Don't put it out there. Don't put it out there. Don't
of course
talk about it.
We
The universe listens. Don't put it out there.
No, that'll be my secret sauce for a high energy density, quick charging solid state battery.
That's his proprietary knowledge right there.
Quick charging, I like that.
Demonstrate.
Cathode, like the solid state itself is one thing, but if you get the right cathode, the cathode is the game changer right there. I've already solved the solid state part. I've already solved the dendrite issue with magnesium. With the solid state, I don't get dendrites. Okay, because there's no galvanic reaction happening in the cell. This is all microscopic, micro tunneling.
Mike, we need to talk again privately, because I do actually understand everything you're saying like no other, and I do actually have that other side of the reaction of the anode nano layering for that same equal zero loss transition for you.
Well, see, the big hurdle, that's why everybody has stayed away from magnesium, because it has 2 charged electrons versus lithium, which has 1. So because the charged particles going through the solid state are twice the size of lithium, it makes a very sluggish ionic transfer from the anode to the cathode. I've solved this problem. This problem is not in my cell. I get an average.
And that's why your cells don't catch on fire or explode either, because you solved it.
Yeah, I could take a drill, electric drill with a carbide bit, and I could drill right through my battery, and it will not catch on fire.
Jesus, and with magnesium, that's dangerous. That's what
That's what I'm saying. I fully understand and verify what Mike's saying. He's solved the problem, and that's why this does not happen.
I could literally.
But yeah, you could easily take a thermal, a thermometer or a laser thermometer and monitor the temperature.
Yeah, well, the key is it's not to get the heat.
It gets cooler, actually.
Right? Yeah, you monitor and make sure it's not rising in temperature.
The reaction, so it doesn't happen. He's already measured all that stuff with the thermometers, and with other energy reactors.
So I could take my cell right now. I could drill a hole right through it, and guess what? My cell will still operate. It will still work, even though I drilled a hole right through it. So try doing that with a lithium.
That's big. That's big. That's unheard of. It doesn't disrupt any. It's consistency. That's
it
really
takes
good.
approximately 960 C to make magnesium explode. Okay. Basically, lithium batteries right now, as soon as they hit about 120, they go critical.
120C, yeah.
Mhm.
Yeah,
Yep.
they go critical.
Mhm.
They go into
Your
blow up.
stay room temperature.
They go into thermal runaway at 120.
Yeah.
Magnesium won't hit that until 960 C.
Like imagine if it's mass produced and it, like lithium ends up in the landfills and it causes all sorts of, problems to the environment. But this one, if it,
Well,
is
the other great thing about magnesium, why I've been trying to figure out the magnesium riddle, is because it has twice the energy density of lithium. So yeah, the sluggish magnesium part, that's been a bottleneck problem that a lot of researchers have had for many years. That's why most battery companies stay away from magnesium, because they don't understand magnesium.
It's the same with aluminum as well in galvanic reactions, and when
Right.
you're able to
That's
nullify
a
a certain
totally different
aspect.
animal.
Yeah,
Between I'm doing and galvanic redox reactions, I'm working at a totally different level than that. There is no galvanic reaction in my
well,
cell, and the
yeah,
reason why I know that is because no dendrites form on the magnesium. The second you have a galvanic reaction on magnesium, 99.99% of the time, a dendrite's going to form. 9 doesn't
absolutely,
have
Mike. And
dendrites.
that's what I'm saying. Like, if you were to add to your cell just on the anode any amount of aluminum, all of a sudden you would get a ridiculous amount of dendrites start forming again, unless there's
Yes.
a specific process that I figured out to solve that. And then you get the same reaction, but without the dendritic form or the galvanic. Um,
See,
figuring
when you introduce a second metal, say like you're talking about aluminum onto magnesium, and if there is any liquid present, guess what happens? That aluminum actually becomes acidic, okay? Which makes it even worse, which makes it even hyper accelerate dendrite growth. So you see what I'm saying? There's
we
other
would have to
reactions,
go like
side
up on,
reactions.
wouldn't we have to like go on the periodic table to
oh,
see, which
absolutely,
one
Oh
Mike.
yeah.
matches with which
Oh,
one?
Yeah, no, 100%,
I've been
Lou, and that's a big part of it, and more complexity, and it goes into more of the proprietary knowledge of development. But with what Mike was saying in the moisture, that's the key to why Mike's cells are able to last is the solid state, and that the moisture you get as soon as you get that in, it's instant super galvanic and dendrite because it goes into the electrolysis aspect, and you're getting the electrochemical breakdown consistently. You're getting more energy out, but it just fries it, and that it's being able to incorporate the additional elements and metals on the anode and cathode sides without interfering in the reaction and triggering that water style of galvanic interaction or electrochemical, and it just still remaining all solid state
yeah.
throughout.
And like my cell is 100% magnesium. There is no other elements involved there. And now that's where now the solid state electrolyte comes into play. What's in it to make it do what it's doing? And why is it able to prevent a sluggish magnesium ion flow through the matrix? And that's where it transfers into the cathode. In the cathode, I made some discoveries this week that will exponentially increase the ionic charge within a cathode per square centimeter. So
I want to try.
it's
You know what
starting
I
to come
want to
full
try, Mike?
circle.
I want to try
What's that?
your cathode in the center of my coil.
Oh yes, see, and what you're both
I
you're
kind of
both right
wonder.
now on the key parts of what I've been developing and like experimenting and making the vastest discoveries of over the last decade and a half with the cathode and also the anodes and uh, well, the different types and forms by increasing like surface area exposure for one, and then the nano lattice layering of different nanotechnologies across them, and then as well as the triple magnetic fields from working with the triple solenoid coils as the electrodes and the cathode and anode and the nano coating layers within them. And then you're getting into the super complexities that actually are able to create metamaterial exotic matters as the production of some of the certain deposits of those reactions.
Well, that's a mouthful.
Gerald.
Yeah,
What
truly
if
was,
what
truly
what if
was.
you
Gerald.
cover the cathode and anode in glass? Wouldn't that
That's
stop the
okay.
dendrites?
No, dendrites form on the
It's a
sacrificial
different
anode.
type of reaction that you're thinking of, Lulu.
So,
We'll talk about
Gerald, if you
Yeah.
do what I told you earlier before
Yeah.
we went on, and you encapsulate that graphite in polyethylene and hit it with static electricity, you're going to have a super electret.
No way. Because half my
Yeah.
oh really?
Yeah,
I'll get
yeah.
back to you on
What
the
you're
outcome on
saying is
that one.
absolutely correct. It's absolutely
I'll get back to you on the outcome on that one, because if you're right, you could have just increased my power by double.
Yeah.
And my power's already stupid.
Yeah, because the
polyethylene. Reach out to me.
polyethylene,
I can send you these things and teach you how to make them so you can layer, like, coat everything in different ones to,
You know
like,
what my problem is? I've
magnitude
literally
more.
been captured so bad, Bernie. Like I don't even get emails from Mike half the time. It's
Well, you got
insane.
my phone. Oh, hey, Phil's sleeping, so it's not interference time. So I'll put my phone number, cell phone, in the private chat right now for everyone, and just text me. Add me to
I
WhatsApp,
will.
the Signal, and through there.
I get that. Yeah, I'll do that.
So polyethylene on its own, I believe, has a very high K value, and it holds electrostatic charge extremely well. If you hit it, say, with 100,000 volts, and then you have my superconducting graphite configuration on the inside, okay, now you have something that is pulling and holding on to that electrostatic charge on the polyethylene that's already a very good insulator. You see what I'm saying?
I do. I wonder if that
So-
could be used like if I layer it like a capacitor almost, but
Well, you know what you do after that? You do the Townsend Brown experiment with that.
oh, okay. I know where you're going with that. Yeah, that may enhance what I'm already doing. That may give me something that I've been looking for. I'm gonna try it. Absolutely.
Big time. So I'm gonna do the graphite configuration this weekend, and I'm gonna try it out. I'll build a cell with it, and I'll see the increase in the capacitance of the cell. Because right now, like, it's running pretty freaking good right now on its own. But if I do this enhancement to it, I might get something even more special.
I'm
So-
excited. I'm going to be trying it this week too. That's awesome. Elijah talked about polyethylene glycol. I use that as well.
That's what I use. Polyethylene is on the forefront of battery tech right now.
Yeah, Leglass said that. Joel Legacy.
Joel Legacy. Yeah. Polyethylene glycol. Oh yeah, that is a must in all batteries, solid state and liquid electrolyte.
I still have a cell that shows 3/4 of a volt, and I made it 2 years ago now. I brought it up on your live, I think. Well, maybe at least a year ago. I'm not sure about 2.
Well, my alum crystal cells, the ones that Bendini did, and I did my own version of it.
Yep.
They were sitting for 6 months. I put my probe up to it, and one of them still had 1.5 volts on it, and I didn't even touch it for 6 months. Yeah.
See, that's what gives me wonder if they resonate at certain frequencies. That's why I brought up what you were doing. If I put that in the center of the coil, can I resonate that? Will I be able to input energy into it? You know what I mean?
Well, see, because the Hutchison cell is it's a galvanic reaction, but I also think sunlight or any kind of photon hitting it reacts with the alum and the magnesium, right? And you're getting side reactions. It's actually absorbing photonic energy where you think it has no relevance whatsoever. I do believe, even though you got the sun hitting it, there's an evaporation, so it's like an air cell, right?
But almost like an air solar cell.
Yeah, similar. I think there is a solar radiation or a thermal radiation component to it.
Yeah, there
could its resonant energy trigger starting another system? Because what Gerald was saying that he needed a certain volt to to kickstart his system. So if that resonates enough energy to kickstart that one, then you could just, because this one is riding on something.
My cells, right now, like a couple months ago, I put a couple of videos out that my cells, if I press them together, I get a side nuclear reaction in the cell, and it was actually triggering my what do you call a Geiger counter. So I was I was triggering my Geiger counter to the point where it started beeping.
So there you go, Gerald. That would start your system.
Absolutely. You know what else started my system the other day? I thought was really crazy.
We're talking like self-sufficiency. If there's no humans around and you need this system, do you understand? Like if
you turn the switch on and it's always on, and you get energy near it, it will start on its own. Like I took 5 of my smoke detectors and cracked them open, and
got the aramicium
slowly started to fill. On the start.
Did you use the aramicium 231?
Yeah, that was the only ones I get my hands on.
Aramicium 241.
I call it Americum.
Yeah, Americum. Yeah, because that's how it's spelled. 241. Yeah. Aramicium 241, I believe it is, the atomic weight.
Yeah.
It's
I
inside your
open, and I literally stuck them by my coil system with it on, resonating at a certain frequency, and my capacitors don't fill at that frequency, but they started to. So I believe I was absorbing that.
Yeah, you're absorbing probably a gamma or a beta wave. Yeah,
I'm gonna prove this on video this week. I got a few videos I keep saying I'm gonna release, but I have to release them this week before that whole ID law comes in. I'm running my coil system, and I turn a candle on in the middle of it, and the voltage goes up in my capacitors. It shows that I'm absorbing heat, turning it into voltage. So that being said, because it's switching so fast, it stands to reason that at low levels of radiation, I could absorb that as well.
Now, have you been able to make, like, say, a solar cell that could run at nighttime?
No, but you know what? I have that experiment written down from the last time we talked about that. And I haven't been able to do it because I've been working on other things. But pointing my coil at a solar panel at night is something I still have not done.
Mm-hmm.
And I kind of wonder if it would charge, at least to some degree.
Yeah.
Yeah.
So, like my power cells, everybody's probably wondering, what is my end game with it? So basically what I'm after is a solid state battery that has very high energy density, but can charge in less than a minute. Now, what does this mean? Well, now I can take that and hook it up to my Renegade device and run the Renegade device, produce power for whatever, and also cycle a charge onto it for 20, 30 seconds and would sustain the motor for several hours before it would need a little shock with its own power. So you would have a self-sustaining generator that basically would run perpetually. So that's the end game.
So my end game would be, I want to release 4 different items that could be sold to the public without causing me an issue. And the ultimate end game for me would be a room temperature fusion reactor, just to prove Sal Pias incorrect, because he says that nobody in their basement or garage can build such a thing without millions of dollars. So if Hazmat shows up at my door, ladies and gentlemen, I'll make sure I video it, because evidently they don't want people building this stuff. But I mean, if I could, I'm no genius, but maybe, you never know.
Faraday cage your
Something
house.
like that.
Buy some a copper shielding paint, and then paint all your house like copper. Got a Faraday cage.
Yeah. I'll just put a big cage over the house.
That's it. That's it. It'll look like you're having a wrestling event at your
No,
house.
you shouldn't. Not don't do the whole house. Just wherever you feel it's a threat, because you don't want to cook yourself in it inside of the
Any crazy
bombardment of frequencies. So you
any
still want.
crazy experiments or anything over 12 volts, I actually do outside of the house. I have a special shed that's all built, and it's Faraday caged, and I have a Geiger counter in there, and I don't. As crazy as I talk, I take a lot of precautions. I don't skip safety, because safety is important, man. You screw up and you're dead, right? Like, it's important.
A friend of mine has ordered these World War II Navy spark gaps from radar systems. He got me my first batch. Well, he's got me these new ones that are coming in. Yeah, remember the ones I showed you a while ago? He's ordered these new ones. Look like what Farnsworth was using when he was doing his nuclear fusion experiments. He's got about 4 or 5 of these crazy ass spark gaps coming in. Like these things look friggin' alien.
That's sweet.
And I don't know how the hell he found them, but he ordered them, and hopefully they'll be in the next week or so.
What's the potential that they could convert?
Well, nuclear fusion.
Oh, okay.
See, I don't believe that fusion is in heat. I don't believe that at all.
No, it's self-sustained. It's a self-sustaining energy field within a vacuum chamber. And if you could make a star glow in space in a vacuum and not move and just hold and stay there, that's a fusion. All these guys, what they're doing now with nuclear fusion is they're using magnetic containment to hold this fusion in place. They're using magnetic fields in a chamber. That is so much harder.
At the right time. Sorry to interrupt, but
you're interrupting, Bernie.
You're talking about is the star in the jar. That is the plasma arc between the two electrodes.
Okay, but that's not the fusion reactor I'm talking about.
No, but for fusion, listen to this though. For this next device that I'm demonstrating and doing, the actual star in the jar plasma arc, it's that the arc ionized plasma that's going between the two electrodes, that is the same temperature as the shell of the sun. It's the exact temperature that is where hydrogen is transmutated into helium and fused into helium. And the whole point of my device is for producing helium out of hydrogen, and that it's that same condensed, instead of needing to generate these massive magnetic fields to be able to hold and control and contain that plasma field. Instead, it's being contained within the density of that salt water electrolyte and just being a very small area of where the fusion is actually happening, and thus the amount of energy that comes out is correct of the fusion model, where you get 3 times more heat coming out of the reaction than the electricity.
I understand what you're talking about. You're going right along the same lines as Pons and Fleischman. But me and Mike are having a debate about something different. What I'm saying is I don't believe you need heat. I believe it's more subtle than that. And all the experiments that I've done, they show it, but they don't show what it could be. So, like I said, an attempt at building such a thing, but there's principles that are involved in what I've done that literally create a vacuum between the two coils that are interwoven.
Yes.
at 180 degrees
Gerald,
Celsius,
so
right?
what you're absolutely right on, and what you're talking about, area, is what they call the cold electricity, but the cold plasma, and it's the ionized particles in that cold temperature exchange that you have the same fusion reaction area in, and it's from the high energy charge from your field within the coils that creates that, correct?
Yes. There's a little more to it than that. It has
Of
to do with
course.
plasma being created between the two lines of insulation that are coating the wires, and like there's actually solid mechanisms that are in play in order for it to work. You can't
Yes,
just
sir.
a bunch of wire together and say,
Yes,
hey,
sir.
we got a fusion reactor. It's not about that. It has to do with
No.
geometry. It has to do with phase reverse configuration. It has to do with what you're using as a seed tool, if you know what I mean.
Yeah,
Right?
continue.
So
I love it. I'm smiling. There's a couple more.
yeah, there's a lot involved. How do you pull the energy out of what you're doing in the process while you're doing it, and how do you put energy into the area but not into the actual item that you're trying to
Oh yeah. Oh yes, absolutely. Yeah.
multiply, maybe, if that's
Yeah,
quite the right word.
100%. No.
So I know exactly what's going on. The system that I've been working with is different than what most people are looking at, because they're looking at that. They need 10,000 degrees in order for fusion to occur. Yeah, if you're fusing two metals or two atoms at a certain frequency, perhaps, but that's not what I'm trying to do.
No,
I'm
you're doing
trying,
phase shift fusion,
I'm
which
pulling
goes
the
into
energy out of
higher
the.
mass.
Yeah, I'm doing it completely differently. You're
I
absolutely.
know your type. It's part of my model, and it's the key part of it. And it's where you get the higher density matter, aka exotic matter, because you're getting crystalline, you're getting hydrogen bonds and whatnot out of what's being fused and solidified out together.
I'm using the breaking of the hydrogen bonds in order
Oh
to
yes, yeah,
supplement energy into the system as it's already running.
exactly. You break the outer hydrogen bonds, that is the plasma or ionized bond, and then it's absorbed in as an ionic bond into the substance that you
Okay, but
have.
I don't use, just so that you're aware, I don't use glass jars and I don't use a bunch of water.
Oh,
I use,
I know. It's the exact same process. It's all atoms when they're in an ionized ionic state.
Is it possible to create a standing wave of energy fields? Then you could trap something, because if it's a
Yes,
standing
yes,
wave,
the
then you pretty much.
standing wave that's created in my system is in the center of the coil, but it's not in the center. It's around the inside center of it. The
Mhm,
very center is a null zone.
mhm.
There's
correct. Yeah.
absolutely nothing there. There's no movement. There's no magnetic. There's no static. I've tested. I've proven it. I have all the tools to do it. But at the
So,
same time,
Gerald, we gotta combine our two systems, because your system's like the next magnitude of developing my system that I've been working on forever, that I've been imagining that I need and waiting for. So, yeah.
Hey, Bernie, are you lined up for the Tesla Tech this year?
Yeah. What do you mean? I am co-running there and the opening presenter.
oh,
Oh,
good for
nice.
you, man.
Give us the dates again. When is
August
it from?
12th to 16th. August 12th to 16th. And if you can't be there in person, you definitely have to use my affiliate link that I will post later, because the guy forgot to send it today. Darn you, how to, Mike. But, anyways, point being that it's 5 days of just nonstop breakthrough science and technology presentations by all the top minds, and it's worth watching and need to watch, and next level. And if you haven't seen my presentation yet that I just posted on my channel from last year, well, that's just the beginning. You want to see this year's presentation called
I
Hydrogen.
saw I saw the presentation you did last year. It was good.
Thank you.
Yeah, I watched it there a couple nights ago.
Yeah, I haven't seen it yet, unfortunately.
I haven't either.
Definitely check it out. It's 45 minutes long, and for the
Can you
first time
post the
ever,
link in the chat for us? Because I'd like to check it out too.
yes,
Bernie.
I definitely can do that.
Yeah, Bernie got a lot of secrets.
Oh, more than probably anybody ever.
Oh, I don't know, Bernie. I got a few skeletons in my closet I won't be bringing out.
Yeah.
Were they left over from Halloween?
They're left over for something.
I'm afraid to ask, Lulu.
His rubber room's still in the space station right now.
Right? How'd you know, Mike? Darn it. I got my
So,
jacket
Lulu,
here and everything.
Lulu, what's going on the other side
All
of
right,
the
there's
fence?
the link. Sorry.
What's
Af-
going
I'll-
on?
After the show.
Okay.
Yeah. Like, yeah.
Oh,
Alright.
that sounds like dirty talk after the show. Ooh.
It's probably as far away from that, as
Yeah.
possible. And that's the truth of it, so.
Well, then,
So, hey, Bernie,
take my word for it.
hypothetically, if you had somebody on camera that could make things, I don't know, hop, would that be cool to see?
yeah, I love watching your hopping videos.
Okay, maybe I'll send you one.
Cool, man. And maybe just call me on my number there, and
Yeah,
show
I've
you
got the
some
number
things.
written down. I'll definitely call you.
Perfect. Then I'll explain all the colors of the rainbow. Isaac Newton's rainbow, though.
After
For anyone with a dirty mind out there, my rainbow is Isaac Newton's rainbow. It's the alchemical rainbow of transmutation and I guess nuclear physics and fusion. I don't know. I think that's kind of the opposite of gay, but you can be queer to it because queer means happy. I guess gay means happy too, right?
You
Whatever.
know
you
what? Hey,
do.
Bernie, when it comes to science, the rainbow's ours. Physics produces it, not gay people. Come on.
Exactly. Hey, but science says that there is gay in biology, but there isn't mutilation. But I'll stop now. All right.
Yeah, we won't get into that topic. One of my best friends is gay. Tells the best gay jokes. I'm telling you.
Hey, there's nothing wrong with the queer, but
He's got some crazy great
the
gay
children.
jokes.
No, just no to children. That's all.
No, none of that. So as the crowd goes silent,
The crowd goes
I'm trying
silent.
to think of something to come
gotta
after
break
that.
that silence.
All right, so here I just harvested some silver oxide in blue, right? And then this one is silver copper oxide. And then this one is bismuth zinc oxide that I just took, right? So we got 3 different types. Then we also have gold oxide as well, all in the blue state. So that's your a certain, I guess it's a magnetic insulator layer of nanomaterial. Then we have the eve state, the black they call carbon state, right? Like your graphene. So Mike, correct me if I'm wrong, but to make your graphene, what you were using graphite originally, or using carbon?
No, use high 600 mesh carbon graphite. All right. And then you're going to mix, carbon graphite powder, the 600 mesh.
But
all right?
graphite, is there graphene in it? Or it's graphite. Yeah, graphite.
Well, yeah, hold on. Let me finish.
Yeah.
So you take a flask and you put a 50-50 mix of isopropyl alcohol and distilled water. Okay. And you're going to put, say, about a total of, say, 300 mil of the water and isopropyl alcohol. All right. And then you're going to take 2 healthy tablespoons of 600 mesh carbon graphite powder.
Huh.
Mix it up well and put it in the ultrasonic cleaner for about 30 minutes at about just before boiling. So between 80 and 90 degrees C. So what's going to happen is it's called ultrasonic exfoliation. So all those graphite particles in there, they're going to start splitting off. They're going to peel into the graphene. So now what you're going to have is graphene oxide.
Yeah.
Okay. And now after that is done, put it through a couple of really good filters. And then you're going to have to get most of the water out, add a little bit more isopropyl alcohol, and you'll have to let it sit for about a week, maybe 2 weeks, for all that liquid to dissipate. And isopropyl alcohol, you got to get all the moisture out. So what you're going to be left with is a black sludge. It's going to look like a big blob of black sludge. That's graphene. So now, if you want to make, say, a conductive paint, you could add a little bit of polyurethane paint, what do you call the polyurethane for, wood, wood curing and that.
Yeah.
You pour a bit of that in, or you could take a little bit of PVA glue, the white glue. You could add a little bit of that to it, mix it really good, and apply it onto a surface, and then you got a liquid conductive ink.
Yep.
That's graphene.
And that's essentially a graphene nano crystal lattice layer that is nano coating. So what you use both carbon and graphite in your process, and it's is it
exfoliation
graphene or is it carbon?
The carbon graphite will do the same thing. It's carbon. So at the molecular level, what it's going to be doing is going to be splitting them in half. It's going to exfoliate, separation of layers.
Okay, so the stuff in the battery that you could pull, like it's a little black tube, is that graphite or graphene?
It all depends. It's kind of hard to tell unless you know exactly what was put in it.
If it's functioning properly, it's graphene. If it's in between, it's graphite, and it's because it's in the EVE state. And so, why I'm asking the whole thing about carbon though is because it's like there's no carbon to come from mine. It's just
any carbon will work. You can take a piece of charcoal from your barbecue, and you can dehydrate it to the point where you can just pulverize the crap out of it until it's like dust. That's graphene. All right. You can exfoliate that doing the same method with the ultrasonic cleaner, and you can make graphene that way by using friggin' charcoal. You know what I mean?
Interesting. Okay.
Yeah.
All right. I got to experiment with this more, and then I got to experiment it with combining mine. Because, I'm not going to go more into it because it is proprietary.
Graphene, if you take your time with it, you can make actually a very good quality graphene. And it's a lot easier. Actually, another method, this one's the one Robert Murray Smith used to do. Get, the mixers, you make your shakes in, all right? Puts in graphite powder, puts in distilled water, fills it up, and then he adds dish soap to it and then blends it for about 2 hours. And then when you're done, you got graphene. So, there's so many different methods that you can do it. And all you have to do is put it through a bunch of filters until you get that black sludgy material. And there's your graphene. So there's just different methods. Some are a little bit more caustic than others. Some people like to use sulfuric acid to do it. Yeah, it works well, but it's extremely dangerous for one. It's harder to purify it too, so it's not dangerous.
It's a high chemical reaction and cost to it. And that it's only with graphite and carbon as the two elements in that graphene, and that the states I'm making copperine, I'm making aluminine, I'm making zincine, I'm making goldine, and that these all are the ones that Mike will be talking about of using on your anode side for your reactions that will not create dendrites in the solid state or any loss. But I'm not going to go more into that here.
Yeah, that's That's stuff that what I'm doing with the cathode right now is so critical to the performance. As far as the anode and the solid state electrolyte, I've got that down packed. Like, I'm very satisfied where I'm at with that. It's the cathode. If I can make the cathode absorb energy 50 times higher energy
Yeah.
density.
So I guess it would be the cath. If you got it's the anode, then yeah, it would be the cathode side that you'd put this stuff on and mix it with, and probably do better than 50.
Yeah, 50x. So I'm going to do that this weekend.
This
I've got all the
probably will
materials.
be like 10,000 or like more. I don't
Well,
know.
it would, like if I make a cell that's say like, 900 milliamps, I might be able to get 1800 out of it. You know what I mean? And also the amount of current flow, my internal resistance of the cathode is now going to go to almost completely zero. So if I hit zero on resistance inside the cathode, basically I've got not only I got a super battery, I've got basically a room temperature superconductor.
What are you using for the anode again? Like, that's not your graphene part thing, is it?
No, the cathode it's graphite. It's
No,
graphite.
the anode.
Okay, right.
Anode.
No, the anode is magnesium.
Gotcha.
Right, now I remember. Okay, I just had to, because I know what you're.
So the key is not even the sacrificial anode is not even the key to the whole system. The key to the system is your cathode. And that's what I'm starting to understand what Michael Kantz was doing with his power cells before he died. Now, I talked to his neighbor out of the friggin' blue about it was just after Christmas. This guy calls me out of the blue. Actually, he sent me an email first. And he goes, I have some interesting information about Michael Kantz you might want to hear. So I made the long distance phone call into the States. I'm not going to say what state he was in. But anyways, I talked to him for about over an hour. Cost me almost $100 for the phone call. He grew up with Michael Kantz. And he was talking, he's still in contact with Michael Kantz's sister. And under the circumstances of how he died, he believes that he might have been targeted. And he used to work for Bell Labs.
Yeah, I've seen he had a beautiful system before he died, man.
Yeah, he had a really good over Unity system. But anyways, now I'm starting to understand that actually it was his cathode which was the revolution.
Wasn't the machine the anode?
Well, no, it was, he was making like a crystal cell in those plates, right? They put each plate put out about 1.5 to 1.8. Where I'm at right now with my cell, I'm actually doubled his power.
Yeah, but his amps were stupid, weren't they?
Yeah, but mine are my cells are putting out between 2.5 to, I've actually spiked it. I spiked it over 10 amps a few times. Nice. So that's a non-resistive dead short, right? But irregardless, 10 amps is 10 amps, right?
Yep, it is.
So to certain systems, pumping a 10 amp current through a coil that, even though it's non-resistive load, it might go to half, or even if it's a quarter, you're still in, 2.5 amps.
Yep.
So that's a lot of current flow.
Would you sell like that?
Would you have to convert a lot if you want to do the 240 volts versus the 210? Like, because in Europe it's 240. They run off of and here.
Well, if you're doing an inverter system, your cells, as long as they're 12 volts, you could run an inverter, and then the inverter just inverts that power into 240 or 120 depending on where you live, right?
Yeah, and it would just depend on how many amps you have as to what load you could use.
Right. So, my cells, what I would probably do, a smart thing to do so they last longer, is put them in tandem with a set of super caps.
Oh yeah.
So when you punch a heavy load off your inverter, instead of pulling it right from the battery, you could pull it off the super caps, and the super caps will shield your power cells from getting overheating. Because if you pull continuous 2, 5, 10 amps continuous out of your cell, it will build up heat.
Really?
Yeah.
Huh.
So
Well,
you're
graphite, right? Like so.
well, it's graphite, but it's also the stress on the sacrificial anode, right? Whether it's lithium or magnesium, it doesn't matter. There is going to be some heat, especially if you're pulling high amps for a long period of time. So you want to buffer that. So you put super caps in front of it. So when it pulls a big load, the super caps is what's going to throw the amps, not your cells. Your cells are just going to trickle that charge back into your super caps. So, yeah, whenever you run an off the grid system like a solar system, I always put super caps with the 12-volt batteries that are running the inverter always.
Yeah, it makes sense.
And the other big thing too is critical, especially if you're using 120 volts at, a 2 kilowatt system. I've got 1 gauge power wire going to the batteries. Yeah. So you can't use an 18 or a 20 gauge wire to do that work. You'll burn the wires out. So I went heavy duty. I went to a 1 gauge. Actually, one system I built's got 0 gauge. So
0 gauge is good. I actually just watched a solar channel do an experiment over 420 feet from solar panel to his house, but he used, he overgauged the copper line that it was required for. I think he used 1 gauge and it was only asking for, I think maybe 10 or something like that. And I'm not even sure.
Yeah.
But he lost half a volt and he didn't lose any amps over 420 feet.
It's because of thick wires. Like DC for traveling distance is not good. That's where the war started with Edison and Tesla, because a DC, you're sending a DC current down a thick wire, and it has to be thick, otherwise you can't get any current out of it. And number two, it bottlenecks the power, so every kilometer you'd have to put another station there to keep the line going, because DC can't travel distance where AC can, and that's why Tesla won, right? And Tesla could use a lot thinner wires. You didn't need like huge friggin' cables, 4 inches thick.
Yeah, you're not wrong.
Yeah, DC is meant to be close by. It's not meant to be a long distance travel with DC. It's totally impractical.
See, and the funny thing is, you can run your whole house off DC. If you converted the AC from your wall, you would you'd probably save money, honestly.
Honestly, AC is only good for power transmission. That's all it's good for. Because if you look at our house today, our TV, our most of our units that take power, a lot of it's all powered by battery, or it has a transformer pack that you plug into the wall and converts to 120 to a DC power source. Like perfect example, my laptop.
Didn't you say that DC was more efficient these
days?
In
the old houses, and now you're getting into the quote-unquote Tartarian technology, but basically it's just electricity before Edison and Tesla, and that's why it was decentralized. Everything was made off of DC power generators at home, and it was like even running your water, you'd be able to, like your tap, you'd hook up a little device, it would be like a little hydro generator.
For the centralized power system, they went with Tesla because they knew now they had a means of getting power to every single house and control and always be able to charge people for power. Where Edison, if he got his way with battery and you were able to have like a unit outside your house, the size of your air conditioner outside of your house, you would have an off the grid house self sustaining system, right?
Yeah.
You wouldn't need the grid. You wouldn't need power stations. You wouldn't need any of it. So it's funny how now we're starting to see we should have actually done it Edison's way. You know what I mean? Because now the cabal controls the power grid. They control all the centralized power system. The Department of Energy, they have full control over everything.
Exactly, Mike. And that's what I've been saying a bit of, like, Edison wasn't all bad. I think they played Tesla and Edison off of each other, and then they actually scammed all of us by making one evil and selling us the narrative they did.
Yeah, I think Edison was, at that time, he was ahead of his time. They didn't see the vision of what Edison wanted to do. Where with Tesla, all they saw and only saw was dollar signs. Yep. How they would be able to make money with
they could have used both. They could have used Tesla for transmitting all that power long distances, and then used Edison's DC, all his
ideas. But Edison was, I think, a little bit ahead, visionary of what's to come down the road, because it's kind of impractical to say, okay, I got to power my cell phone, but I have to have it plugged in the wall all the time.
Yeah.
Oh yeah, I got to walk around with a cell phone that's plugged into a wall, right? So you know what I mean? Like,
I do.
Have you guys noticed, since I asked Jarvis if he was part of an undercover operation, he's not showing up anymore?
Well, that's funny. Jarvis. That's funny. The only thing I didn't like about Jarvis, like, every time I went to talk, he
Jarvis is just one of several different spooks on this show. Come on now.
Like that guy Bernie. Every time I go to talk, no, I'm just kidding. I'm kidding, Bernie. I'm messing with you.
If they combined
white hat spook number one. I am a spook for the large white hats, the opposite of the dark tiny hats. Yes.
You twist my brain, Bernie.
Good.
Go ahead.
Good.
Well, we're at the top of the hour. We got another 9 minutes. Okay, you know what, guys? Just do free for all for the next 10 minutes. I'm going to go for a quick smoke. Be good. Don't say anything.
Quickly share, load that my presentation there. Play a minute of that if you don't mind.
All right. Yeah, we could do that.
We mind, Bernie.
Yeah, give me the link there and then...
just messing.
Oh, you got it there?
Link is in the private chat.
Is that from...
okay.
Let's Tesla Tech. So everyone, go to Tesla Tech, August 12th to 16th, Albuquerque. This August, it's the best. And this is a bit of my presentation from last year.
I wish I could.
Just bear with me for a second here.
I'll be there in spirit.
Well, exactly, Jed. And for just the reasonable price of $100, everyone can be there in spirit and streaming the entire presentations all 5 days. And it's on demand. You get to keep it forever. So, be there, digitally and in spirit as well.
$100, eh? Huh.
All right. All right, you guys see it? Okay, I'm going to play it. I'm going to go for a smoke, come back, and yeah.
Yeah.
Can you guys hear it?
Production team for the first several years. We made all sorts of plasma fields with coils. I learned nanotechnology, and I learned what he calls GANs, gas, atom, nano, solid state. And here are some of the different plasma coils and such that I made with him and nano-coated. Oops. All right. So we got GANs, acronym gas, atom, nano, solid state. So what is that? Well, that is David Hudson's ORMUS, orbitally rearranged monoatomic elements. Also, we have monoatomics, which just is that monoatomic, that single atom. And I have been able to produce gold, silver, copper, iron, lead, bismuth, tungsten, aluminum, and several other metals, all in this pure white metal monoatomic state. And then there's also monomolecule, and I have to give a shout out to another presenter here later, Jared Polak, for coming up with that term. And monomolecules are then the monoatomics when they either oxidize and turn blue. You have a diatomic, and you don't want that. That will kill you. Diatomic equals dying. That's why you see, well, people drinking this colloidal silver turning into blue Smurfs and dying. You don't want that. And then what you really want is the ionic water. And the ionic water is when your monoatomic bonds in with the water and is able to be fully absorbed into your body. And my belief is these materials are a low energy cold plasma nano state. Here's a few examples. On the left, you have the purple monomolecule, and that specific one is monoatomic gold or monomolecule gold. I formed the gold into the white monoatomic state, then I exposed it to the full sun equinox, at which point the photons bonded with the monoatomics into these purple monomolecules. In the middle, you have the red state that the alchemists call the 6th transmutational state of metal elements. I believe this to be a cold red state superconductive, potentially straight hydrite. And then on the far right, you have monoatomic gold with nano gold bonding together. Here again, you have the monoatomic or monomolecule gold, where it's both the monoatomic as well as nano gold clustered. And then on the right is the pure white monoatomic gold. All right, and then here you can see several different colored states, and I've got silver, zinc, and gold in the purple states. Silver also I exposed to the full moons, and that is how I got it from the white state into the purple state. Zinc, well, I'm not going to cross that Rosicrucian line yet and disclose that. Okay, so now we got some more once you mix them up. So here you can see the water at the very top. That is your ionic water. I pour the water out, and then I refill it with normal water. That's while it's mixed. You don't want to drink that. You will go crazy. On the left, you see a little bit of the blue of the oxidization. Now we have Sir Isaac Newton. And Sir Isaac Newton, after I started experimenting with Keshe's GANs, I was able to find Sir Isaac Newton's alchemy translations and what he called the 7 colored states of transmutational elements. In this, I am directly stating, I am not claiming that these 6 other original transmutational states are actual transmutations of elements. They are, in fact, it starts with the pure white monoatomic, it goes to the blue oxide, then it goes to, well, we'll go through that. All right, there we go. We got the black, the white, blue, green, the yellow, red, and the pink crystalline state. And it is in this pink crystalline state that Sir Isaac Newton states that one metal element can be transmutated from one element into another. So first off, here's the black transmutational state. They call it carbon. What it actually is the specific element you are working with, but it has broken down. What you do is you break down the covalent bonds on the outermost of the element. And by doing this, it turns black and you're breaking down. So there's just one little covalent bond left attaching to the rest of the metal element. And when it does that, it is then able to interact with the water and the plasma fields, and you're able to create atomic hydrogen, and you're able to create your monoatomic elements. And the middle picture, so the middle picture here, sorry, the black coil, that will actually, and I didn't believe Keshi when he first started saying this, it actually happens all on its own. The metal will do that, and it even coats metals under the plastic insulation, which is just mind-blowing how it does it. Next up is the white color state that they call the calcium state, and there's actually two types of white states. Now, the one on the far right, you can see it's very white, and that's the actual calcified state that they say. Again, I'm not saying this is a transmutation into calcium, but what it is most likely is a very acidic hydride. When you have, it's in the most decayed phase of the transmutational states, and when you touch this white state to another metal, it will literally burn through that metal. And I believe it's through an acidic reaction. In the middle there, you have white nanotubes growing.
Stop. You've been over 2 hours, Mike, but that was worth it, I think.
Yeah. I'm gonna stop it there. I'm gonna post a link.
But before you cut it off,
everybody
what did you guys think? Any questions from that so far?
Where'd you get that cool hat?
Grassroots California. That shout out to my man Max. All my hats I wear are Grassroots California. Go to Grassroots online, and he makes the dopest hats around.
Right on. No, I got no questions till I finish watching it. I got it in the background. I'm gonna watch it later.
All right. I think you're gonna have. You'll probably have many shows. You're gonna like it.
Okay, so oh, sorry. What the heck did I do here? Wrong place.
Get rid of live screen.
All right, so yeah, I'll stop the share there. All right, so I posted. Did it get posted? What the heck?
Oh, I think you posted only in private chat.
Post something.
Yeah, I saw a post.
No, it's in the comment section too.
Perfect. Thank you.
Did I get it in the comments?
Yeah.
You posted the death metal concert. I think it was the wrong one.
That will happen. Like, you guys are, well, Phil still experiences it out in Quebec, but Mike is definitely from the age bracket of the long-haired hairspray death metal bands from the 80s, right?
Sepultura all the way, man.
Yeah.
That's funny.
Mushroom head.
Mushroom head.
What do you mean? It's not cool to, like, you know, what do you have long hair in the back and short on top?
All the mullet.
All the bullets.
The mullet.
I look the absolute worst with a mullet, let me tell you. It's gross.
I had a fro, so because I got curly hair.
You had a fro.
Yeah, I had a fro back in the day too. It made me look like I was a tiny hat, so I had to get rid of it because of my curly hair.
I look like Richard Sambora because my hair was so curly and puffy. It looked like I always hairsprayed it, but I didn't. I just had really curly hair.
We had the era of where you flip your bangs, the higher they went.
You shaved one side.
No, you sprayed it, hairspray, and it had to, like, you know, stand.
Yeah.
Oh, it's called the rooster bang, you know, because it looked like yeah.
I used to have bleach blonde hair when I was younger, and it was natural too.
Oh my! It was natural.
It was natural.
Blonde.
Very natural.
Very natural. Blonde.
Now my hair is gray. Now it's gone gray.
Now it's naturally blonde-ish.
Gray? No, gray.
So
I even got it in the beard too.
Do you remember the days of the skinheads?
No, nobody remembers skinheads. No one wants to remember skinheads, and we don't like skinheads, so let's not mention them.
I remember pummeling a few of them.
We'll try and be non-violent.
I mean,
Almost
playing
skinheads.
pool
Okay.
with them. Yeah. Right.
All right. So I just wanted to show before we go, I'm making these like, well, what Keshi calls GANs patches, but they're different monomolecules of the different colored states, and that then they're packaged within each other so that there's like 4 of them sealed within each other, where it creates a differential of polarized charge flow between both the oxidized, hydride, and neutral state, as well as the differences in the atomic charge differential between them as well, for like stacking and battery, Provalic stacking.
Well, that was a whole lot, Bernie. I thought you were just gonna say you were making brownies.
Well, fuck, that's on Sundays in the kitchen.
See where he's at right now? I was in Bernie's lab, so I know what he's got going on there.
Mike has been here in person.
That's
In
crazy,
person.
man.
So you're a witness.
He bore witness indeed. And you bore witness to me here, Phil. We met in person at this stupid alien con biomed event. That was something else.
Yeah, but I think it was a good thing I was there too. But no, I'm
Oh
not
my
gonna
God, you're my
elaborate.
savior. You're my savior from the lies and rumors. It's ridiculous.
Yeah,
But anywho,
crazy.
story for another
Anyways,
day.
yeah, I guess we're going to square it up here. Everybody, we go live here every single Friday at 9 o'clock Eastern, 6 o'clock Pacific. Don't forget to join the Faraday Research YouTube channel. It's only $3.99 a month. Also, if you watch the show from the Faraday Research YouTube channel, you could also send super chats, and that helps, fund my projects and stuff like that. My archives, I've got well over 1,000 videos, and I've got about 1,000 videos of live shows with thousands of hours of viewing time. It would take you a year to go through all the stuff I got on my site. So definitely worth the $3.99 a month. Our numbers are up. Our subscribership is up, and we're creating. We're making roads, man. We're creating a path.
I think we have more viewers than the view now, so we beat the view.
Right?
Well,
Exactly.
Well, as far as like say live shows are concerned, we're getting about 15,000 hours of viewing on our live shows.
Oh my gosh! So we're probably beating like NBC by this point.
Yeah,
That's good.
so
Definitely
15,000 hours.
We probably got more viewer hours than the Discovery Channel. I'm willing to bet that.
Yeah, like the numbers are looking really good. I track everything every week, and I was quite impressed. 15,000 hours of watching the live shows. So people are watching previous shows. We've had some really cool guests on our show in the last couple of years. So,
but shout out to all of you guys, because it's all substantial. It's all stuff that we create ourselves. It's not like, oh, I read this in a book and that in a book. All of you guys are creating this, so a lot of respect for you guys.
Yeah,
that's why it's the League of Extraordinary Inventors, because you read the book first, but then you got to actually invent something out of that.
Yeah, exactly.
I love to experiment and invent. So everything that I've been doing lately is all going to come out real soon. I hope you pay attention to my channel this week. I'll have some videos out on certain things.
Right on.
All right.
Okay, on that note, everybody have a great weekend, and we'll see everybody next week. Take care.
Cheers.
Ta-ta.